In this video, we're going to do yet another graph based on transformations. So we're asked to graph the function f of x equals 2 times the quantity 1/2 x minus 1 squared, and then plus a 1. So we have 4 transformations again that we see. I see this 2, so it's going to be a stretch or a compress. The 1/2 multiplied by the x, it's also going to be a stretch or compress. The minus 1 is going to be a shift, and the plus 1 is going to be a shift. The base graph that we'll start with will be y equals x squared. This one I'm going to change the scale a little bit to start with. Let's do 1, 2, 3, negative 1, negative 2, negative 3, 1, 2, 3, negative 1, negative 2, negative 3. So y equals x squared goes through the points negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and we get this nice parabolic shape here. That's our base graph. Let's go in order from left to right with our transformations. First thing is we see a 2 multiplied on the outside. That represents a vertical stretch by a factor of 2 in this case, or multiplying all the y coordinates by 2. Again, the easy way to do that is just to multiply your scale by 2. So you get 2, 4, 6, negative 2, negative 4, negative 6. Done. Don't have to redraw a new graph. Literally just change the scale. Second one, I've got a 1/2 multiplied by the x. Remember, when it's on the inside, we do the reverse. We divide by the coefficient. So this actually also represents a stretch. This is a stretch horizontally by a factor of 1 divided by a half, or also a factor of 2. Remember, when it's on the inside of the function, we do the opposite operation, essentially, for the stretching or compressing. We divide by the coefficient rather than multiplying by what's on the outside. All right, so if we multiply everything by 2, again, we can change that easily just by changing the scale, multiplying the x's all by 2. So we get 2, 4, 6 on the right, negative 2, negative 4, negative 6 on the left, instead of the 1, 2, 3, and so on. That minus 1 on the inside of the squaring is representing a horizontal shift. Again, straightforward way, I think, to find that is to set what's inside equal to 0 and solve for x. When we do that, we get x is equal to 2. 2 represents that we're going to shift 2 units right. Well, now remember, we changed the scale. So shifting 2 units to right is just going to move the vertex to here, and the other ones in the corresponding spots. Remember, this jump from here to here is 2 units, not 1, because we changed the scale. So our graph then is going to look like this at this point. Again, still looks like a parabola. Just shifted over 1. And then finally, the last thing we have, that plus 1 represents a vertical shift, and we're going to go shift 1 unit up. Now remember, again, we've changed the scale. So shifting 1 unit up is going to go here, right? Not all the way up to here, because that now represents 2 units. So we're going to go 1 unit up, 1 unit up, 1 unit up, 1 unit up, 1 unit up for all of those. And now graph that one. And so the red graph represents our final graph.